In this video, I intend to show you two things. Distance from point to plane, and later on, finding foot or perpendicular from point to plane. When we say distance from point to plane, we refer to this distance here. This is a point P with position vector P, and this is the plane r dot n equals d. Seen from far is like a straight line. Notice that I've used d instead of p. I prefer actually to use d rather than p in my notation. I've noted this vector as OP, or p with a wavy line below. I intend to show you how this distance is actually found using this. To start off with, I will first and foremost mark down a generic point on the plane. A generic point on the plane can be marked as just R. Okay, this looks too vertical. It may give you a wrong impression. Okay, let me mark like this. A generic point on the plane. This R. Right. So I have a generic point on the plane marked arbitrarily, and then from this generic point on the plane, I can actually find this green vector. This green vector will be R minus P. On this diagram, I will also mark the vector n. How do I mark the vector n on this diagram? Vector n is just perpendicular to the plane, right? So I can mark the vector n like this. But because n is a free vector, I could also mark the vector n like this. By marking the vector n like this, you begin to realize that the distance that you intend to find, this distance that you intend to find, is actually the length of projection, of this vector onto the green vector. And if you recall, to find the length of projection of one vector onto another, it was given in earlier WhatsApp messages. You just take this vector r minus p dot with n hat. But instead of writing an n hat, I'm going to write as n divided by a's modulus. And for the numerator, I will just expand it as r dot n minus p dot n. According to the equation of the plane, r dot n is simply d. And there you are. You have now the distance from a point P to a plane. These two are actually the same. It's just that this is written the other way around. Alright? So next, I intend to tell you how you can find the foot of a perpendicular from a point to a plane. If this is a point P, the foot of perpendicular is a point F here. Finding the foot of perpendicular from a point to a plane means to find this vector. Make no mistake about it. To find the foot of perpendicular from a point to a plane, you are asked to find OF, right? To find the foot of perpendicular means to find the vector OF. F is the foot of perpendicular from point P to the plane, but if you're asked to find the foot of perpendicular, you're actually asked to find OF. And how do we go about finding OF? You want to start off by writing down OF as equals to OP plus PF. This is from simple vectors, the sum of two vectors, right? OP is P. Make a guess, what do you think I'll write down for PF? Now, in this diagram, the vector n is perpendicular to a plane, so I can draw it like this. Looking at this vector n and this PF, you will realize that actually PF and n are parallel, so I can write PF as a multiple of n. I want you to note that up to this point, P is known. Why is P known? It must be given to you, right? The point must be given to you. N is known. How is it that n is known? Because it's from the equation of plane. But what is unknown here is lambda. We therefore need to find a value of lambda that corresponds to the vector OF. And how do we go about finding this value of lambda? Because this point F is on the plane, because this point F is on the plane, in example 4 of your notes, right, we learn if a point is on the plane, that point will satisfy the equation of the plane. Which means I can put this vector in place of r here to give me p plus lambda n dot with n equals to d. And bear in mind that d is known from the equation of the plane, n is known from the equation of the plane, p is given to you, n is given from the plane. What is left to find is actually lambda. So you use this expression to find lambda. I missed out something here. What did I miss out here? A dot product. Right, a dot product. Right. So you perform p dot n. From here you can just perform p dot n plus lambda n dot n equals to d. And then you can then find your lambda as equals to p dot n divided by, and with the value lambda found, you just plug it inside here, you will be able to get the vector OF, and that is actually the foot of a perpendicular from the point P to the plane r dot n equals d, and that's it.